Hey guys, welcome to Pepcoding. So in this video, we are going to discuss our new question of searching and sorting series, that is first bad version. So in this question, what we have to do, suppose you are a product manager and currently you are leading a team, right? You're working on a product and certainly somehow your product fails quality check. So all the your one version of your product fails the quality check, and you have made certain more versions after that version, right? And you have so it means, since version is developed based on the previous version, it means since each version is developed on the base of the previous version, all the versions after a bad version are also going to be bad, right? So suppose you have n versions and you want to find out the first bad one, because after finding the first bad one, you get to know that all the versions that are made after the first version are also going to be bad. So you can simply discard them. Okay. So you are given an API bool is bad for version that will tell you if a version is a bad version or not. Okay. So first of all, what we have to check, we have to first of all find out the first bad version. First bad version that fails the quality check. Okay. Now first of all, suppose let's say my range is till 1 till my range. It means suppose I have made, let's say, 50 bad versions. Okay. Sorry, 50 versions of my product. Now this is my 25th. That is my 25th. It fails the it fails the quality check. Alright. So this is my first bad version. Okay. So now if I say I have to check which was my first bad version. Okay, how am I going to check? I say I check this version. If it's bad, if it's not bad, then I check. If it's not bad, then I check the second one. If it's not bad, I check the third one. It means I'm going to check each and every element. So it will become equal. It will be a linear search, right? So I don't have to do that. I have to optimize my solution, right? So I know what is my low here. I know what is my high here. I mean, I know my first bad version and I know my last bad version. I know my first version and I know my latest version of my product. Okay. So what am I going to do here? I will make a mid. I will calculate my mid and I will check if that version is a bad version or not. So 1 plus 51 by 2, that is equals to 51 by 2, this is equals to 25. So, alright. So let's suppose this my first bad version is not 25, it's something else. It's, let's say, it's 32. Okay. Let's suppose my first bad version is 32. Now my mid is here, that is 25. So I will call my method, that is, I will check if this 25 is bad or not. So it will return false because my first bad version is 32. So 25 is prior to my first bad version. So it will return false. So if it returns false, what does that mean? It means if this version of mine is not a bad version, so all the versions prior to this version are also not going to be bad version, are also good version. It means all these versions are going to pass quality check. So it means I have to look here for my first bad version. So what do? I increase my low to mid plus 1. So now my low become equal to what? Low is 26. My high is 50. I again calculate my mid. 50 plus 26 by 2. Okay. So it is equals to what? It is equals to 76 by 2. Right? Which is equals to 38. 38. So now let's check here at 38. Now my range is decreased now from 1 till 52. Now my range is decreased from 1 till 52, 26 till 50. Okay. And what was my mid? My mid was 38. Now this is my mid. And my first bad version is, this is 38. My first bad version is 32. Alright. This is my first bad version. Okay. Now I will check is bad. Is my 38th version bad? So it will return true. It will say yes, it is bad. Okay. So if it's bad, it means all the versions after this are also going to be bad. I don't have to look for my first bad version here, right? So what do? I decrease my high to mid minus 1. Okay. Now I'll check for my first version here, first bad version here. Okay, now my high becomes what? My high become equal to 37. Now my high is 37, so my range now is what? 26 to 37. Okay, now this is my low, this is my high. I calculate my low plus high. This is 26 plus 37, which is equals to 63. 63 by 2 is equals to 31. Okay, which is equals to 31. So now I come here to 31. Alright, I check if it's bad, so it will say no, it's not bad, because 31 is lesser than 32, which is my actual first bad version. So it means this area is also going to be a good version, right? So I discard it. I search here. Now I search here for my first bad version. So my range is now 32 to 37. Okay. Now my range is 32 to 37. Okay. Alright. Now I again check. This is my low. This is my high. Low plus high by 2. It gives me was 32 plus 37 is equals to 69 by 2, which is equals to 34. Right, which is equals to 34. This is my mid 34. Is it a bad version? Yes, it is a bad version. Then do what? This is this. Then this, all these versions are also going to be bad. Then decrease my high to mid minus 1. So now my range is, my low is 32, my high is 33. Okay, so this is my range. It's my low, this is my high. I again calculate my low and high. 32 plus 33 by 2. So it means I again calculate my mid, which is 32 plus 33, which is equal to 65 by 2, which is equals to 32. I check, I call is bad 32. It will return true. Right? If it returns true, now my low is increased to, sorry, it is also bad version. So now what? My yeah. So yeah, it is going to return true, right? So I will. It means it is my answer. This 32 is my answer. 32 is my bad version, right? And 33 is my, like, is also going to be my bad version. So I will decrease my high to mid minus 1, right? So now my high is also equals to 32. Low was equal to 32. Now my high is also equal to 32. Now I again check plus, if 32 plus 32 by 2, that is, I now my again mid is again equal to 32, right? It checks if my 32 is a bad version. Yes, it is a bad version, and my low is my equal to my high. So it means my 32 is my first bad version. Okay, because now I have no range to check, and this is my first version. I again say this was my low, that is 32. This was my high, that is 33. Okay, I calculate the mid for this, that is 32 plus 33 is equals to 65 by 2, which is equals to 32. I check, this is my bad version. Yes, it is. If 32 is a bad version, all the versions are going after this are also going to be bad. So my low come here, my high come here. Now my low is equals to my high, and this is my bad version, right? This is also my bad version. So this is going to be my first bad version. Okay, so I hope I was able to make it clear to you. So let's try and code for this. First of all, my low is equals to my first version, and my high is equals to my nth version, right? And int first bad version, first bad is equals to initially minus 1. That is, I don't know what is my first bad version. So while low is less than equals to high, do what? Calculate my mid, which is equals to low plus high by 2, and then my answer, bool answer is equals to is bad, and check my mid. If it's bad, that is, if answer is equals to true, then do what? Then reduce my high to, high is equals to mid minus 1. It means all the versions after my mid are also going to be bad version. So reduce my high to mid minus 1. Okay, else it means if it's not a bad version, then do what? If it's not a bad version, then all the versions prior to the current version are also not going to be bad. So increase my low to mid plus 1. That is search in your right. Okay, and here if my version is equal to, if my version is bad version, then I also have to update my first bad version is equals to mid. I should update it first here. Okay, I is equals to mid 1. Alright. Now let's do what? Now return my first bad version. First bad. And now let's try to run this. Okay, accepted, and let's try to submit this. Okay, submitted. So I hope I was able to make it clear to you that why I'll be using binary search here. So I hope you like this video, and if you like this video, please like, share and comment, and thanks for watching.